Hello and welcome to the loops tutorial. In this tutorial, we're going to be learning a bunch of different ways to loop through systems because there's more than one way to do that. And you're going to want to use different ways for different situations. So let's take a look at some of these methods. So the first thing I'm going to do is go ahead and add an empty, and I'll call this spawner. I'm just going to put it up a little bit in the scene. In here, I just have a big floor. It's a giant plane colored blue, so we can see the items that are spawned against it. And then I also have these prefabs. I have a gray cube and a gray sphere. They both have rigid bodies on them, so they'll bounce around in the scene. That's what they look like. I'm gonna get rid of them from the scene though. And in our spawner, I'm gonna add an FSM, and I'm gonna throw in a create object, and we'll have it spawn a cube. And the spawn point will be where our spawner is. And I'm just gonna move that spawner up a little bit so it doesn't collide with the floor. We'll have this store the object as last spawned cube. And then we'll have this loop state action. And you can see here it says put this action at the end of the state to loop through all the actions in a state specified number of times. So it'll loop through this state, let's say 5 times. And then the finished event will be called next. And it'll send off to the final state here. So here we're gonna have spawn, and this will be complete. All right, so let's see what happens when we run this. Okay, 5 cubes, simple enough. Ran this create object, then it ran this loop state 5 times. So basically it ran this create object action 5 times, and then it went to complete. So the other way that we could do this is using a loop action, which is similar to loop state, except it makes use of events and transitions instead of just looping through the state that it's in. So you might want to use this for something that has multiple states, something which has multiple steps. So I could put it here. I could say I want to loop through 5 times, and then loop event will have a new event called loop, and it could like send back to itself or something like that, and then the finished event can still be next. If I run that, it'll do the same thing, right? We still get the same effect, just done a different way. But the real power of this one would be in something like looping through to some next step of the process. Let's say if we wanted to have a set material, and we'll be specifying that last spawn cube, and we'll say, okay, make that a yellow cube. And then when this is done, it comes back here where it runs through the loop again. So now if I do this, it makes these yellow cubes. Now you'll see that we do have this one guy over here that's gray. That's because that didn't get the same effect since it was the last item in that list. Right here, when it finished, it ran the loop, it created the object, but when it was finished, instead of sending here to the set material action, it came here to the state where nothing happens to it. So the way you might handle that is if this loop was its own state at the beginning, if it was set as the start state, and you add these in, and you'll say that, okay, you're gonna loop through by spawning it, and then we'll delete these transitions. So you spawn, and then when that's finished, you go here to set color, and then when set color is finished, then you send back up here to the looper. And when that's finished, it goes over here to complete. So now when I run this, all of them are successfully turned yellow. Okay, and that becomes your system. You start the loop up here, which creates an object, sets its color, and then comes back to loop again until it's finished and it can come over here. Okay, so that's the power of having just the loop action, which uses events, as opposed to the loop state action, which only loops a single state once. Okay, so that's one setup you can have. Something to keep in mind is that you also have, in both your loop and loop state, you have the option to use a variable. So you can always have an int value that sets the number of loops. There's a million different reasons why you might want to have a variable for your loops, but let me just show you one instance of that. So let's just say you are creating 10 things, right? This is the hard-coded way of doing it. We'll still go through this spawn state, which creates the object, but instead of having a finished event here, what if I have a send random event, and I have 2 events here. Let's say that I have a make blue event and a make red event. And then what I could do is have this one say make red and another state called make blue. Okay. And we'll have make blue send to make blue and make red to make red. I'll put the red material in here, and then I'll also put the same thing over here except to make it blue. And when they both finish, they send back up here to the loop. But while they're here, we'll have them add to an array. So say you wanted every blue cube to be added to its own array. Let's make a new array here. We'll call this blue cubes, and that is a game object array. And we'll have another one called red cubes, which is also a game object array. And that way, when we make something blue, we add it to the blue cubes array, and that is the last spawn cube. And same thing here, we'll have an array that adds to the red cubes, which adds the last spawn cube. So when we create this object, it then sends a random event to choose between these make blue or red blue. And when it chooses one, if it chooses make red, then it turns it red and adds to an array specifically for red cubes. Or if it chose to make it blue, then it adds it to the blue cubes array. You can have this final step in here where after everything's done, and over here, instead of setting off to a complete state, you can have it run through a second system. So this new system could be something like make one yellow for each red. And that way, what you could do is have an array length, which gets the size of your red cubes array. So that's how many red cubes there are in your array. And you could store that length as an int value. So we can have this as something like number of red cubes. So you could use that number now in a loop action. Now you could say, I want to loop for however many red cubes there are, I want to do this new system. And this new system could be something like, I'm going to add this loop in and this next. And this will have its own complete state. So everything is done and goes here. But when it loops, it sends off to a new section where it says, we're going to create object, cube, store object as last spawn cube, and we'll have set material. The last spawn cube will be turned yellow. Okay, so we're making one yellow cube for every number of red cubes. Because this loop state, the number of loops is based off of how many red cubes there are. So we can have make yellow cube. And when that's done, it sends back up to here. Okay. And I'm just going to make sure that this spawn point is set at our spawner. Okay, let's see how this runs. All right, so what do we got here? Got some yellow cubes over here. Looks like 4 of them, right? 2, 3, 4. And that's based off of 4 red cubes. We got 4 red cubes over here. So for each of these, it made a yellow cube. And you can see that represented here too. This red cubes array, there was 4 of them in there. So we looped 4 times, which means we created 4 yellow cubes. And there they are. There's our 4 yellow cubes. So that's one system. I'm going to go ahead and deactivate that. And I'm going to make a new game object called spawner int add. Okay, and I'm going to frame up on this, and I'll move it up a little bit so it's not spawning things into the ground again. Right click, add FSM. And what I'm going to do here is do create object, and we're going to have our cube again. And the spawn point will be this new spawner. We'll store the object as last spawned cube. And this time I'm going to create a looping system that doesn't use any of the actual looping actions. Instead, we're going to have an int add, and we're going to have a new variable called number of cubes. And and I'm going to add 1. Okay, so it'll create the object and it'll add 1 to this int value called number of cubes. And then what we'll have is an int compare, and it'll be comparing that number of cubes to 5. And if it's equal, we'll have a new event, complete. Okay, that'll get sent over here to the complete state. But if it's less than, we'll have a loop event, and it'll send back to itself. So this is effectively creating a loop that is dependent on whatever number we set in here. So we should see 5 cubes get created here. Okay, I'm gonna hit play. And there you go, 5 cubes. Okay, so let's say we made those 5 cubes, right? And let's add them to an array. Let's do an array add for each of these. We'll have a new array variable called spawned cubes. It'll be a game object array. And we're gonna add each of those cubes to it, okay? So last spawned cube gets added to the spawned cubes array. Now when it gets added in here, what we could do is, in this next step, we'll have an array get next. This is an action that has looping built into it, but it works only with arrays. So we'll say that we use our spawn cubes array, and what this does is it'll go through our spawn cubes one by one. So in here, let's say there were 5 spawn cubes. It'll get element 0 first, then number 1, number 2, number 3, number 4, etc. So it'll start all the way at the top and go through each of them. You can also use this start index and end index. Now, start index being at 0, it'll start all the way here at the first item. But if you wanted it to skip the first item, you could say starting at 1. Or if you wanted to skip the second one, you could say let's start at 2. Remember, that's because arrays work off of an index that starts with 0. So the first item is 0, the second item is 1, etc., etc. Also, maybe you want to go through the whole thing, but don't do anything to the last one. So you would say that the end index, if the last item is index 4, and you don't want to do anything with that, then you could say stop at 3. So let's take a look at how this might work. I'll set this loop event as loop, and it'll go over here to change color, and then this finished event will say complete. That'll send down here to complete real. and this will actually change it to get next. Okay, so with this array get next, you also want the result. So when it gets the next item from our array, this result value is whatever that next item is. So we can set a new variable called current cube selected. You can also make use of this index. So if it was the first one, it would be choosing, this index would be leading to 0. Okay, so we can, just so we can see this later, we'll have this as our current index. And over here in change color, I'll just have the set material saying that we're gonna change our current cube selected's material to let's say yellow. Okay, so we're creating a bunch of gray cubes, but then they're gonna be turned yellow. And then once that's done, it'll send back over here. So before we have this running, I'm just gonna come over here and say that the size is 0 so it can dynamically be added. Otherwise, we're gonna have some empty values in here. All right, so let's try running it. Okay, so it selected some of those cubes and turned them yellow. That's because the end index we have set to 3. So it only chose the 3 out of 5. Whereas if I change the end index to 0, it just changes the color of all of them. I can also change my end index to 1. So it'll start at the first one, but not do anything for the second, which means that only one of our cubes gets turned yellow. So the last thing to take note of here is this thing called the reset flag. Because what if you run through this whole system and then want to do something and then run through it again? Well, this array get next would have already gone through everything in the array up until whenever you told it to stop. How would it know to start from the top again? Well, that's what this reset flag is for. A reset flag is a way of resetting the loop in here. So this reset flag is a bool variable. Right here, the tooltip says, if you want to reset the iteration, raise this flag to true when you enter the state. It will indicate you want to start from the beginning again. Okay, so what we can do is add a new variable and call this reset flag. And then over here in complete real, I'm gonna change this to complete not so real. I'm gonna have a set bool value, and we're gonna be setting the reset flag value to true. We'll just have this wait action in here. It'll wait a few seconds before sending back, just so we can see it happening up here. It won't happen so instantaneously. And then over here in change color, what we might do is something like set material, and we'll have it choose between blue, red, and yellow. And it'll be changing for the current cube selected. That way we can see the system running and changing the colors. Let's say we want all of them for now too. I'm gonna hit play. Okay. And you can see these cubes are all changing colors. So it's running through and doing something to all of them, right? It's going through that whole looping process, but we're also able to start all over again and loop through every single one of them again. So this is like a loop of a loop. The last thing in this very loopy tutorial is going to be the array for each action. I'm going to deactivate this game object. I'm gonna create a new empty, call this spawn array for each. And add this FSM. We're gonna have a create object in here. It'll create our cube at this spawn point, move it up so it doesn't clip with the ground, store the object as last spawned cube, and then we're gonna have a array for each right after that, and we'll create a new array variable called cubes, which is a game object array. We're gonna say that this cubes array, for everything in this cubes array, so for each cube in it, we're gonna run a whole FSM on it. So we can have a whole system of things happening. So let's create that FSM. Hit this new button, and we'll call this array for each example. And I'll hit edit. And now we're inside the template. You can see right here, we're in this template, array for each. And in here, what I'm gonna do, we'll have a set random material. So it'll say either blue, red, or yellow. And then we'll have a random float, minimum being 1, maximum being 5. We'll store that in a new variable called random float. And we'll use that random float to set the scale of the thing. So what we're gonna wanna do here is say that this will be our selected cube that's getting these materials applied to it. And we'll specify that again. This selected cube is gonna get this random float for each of these axes on its scale. It'll get a random color, and then it'll get a random size between 1 and 5 units. And that's it. But when we're done here, what we need is a finish FSM action. Okay, because since we're in a template, the outside world, the FSM above this, needs a way of knowing that this is all done here. So you just throw this at the end, and the FSM above it will know that it's done. Now I'm gonna hop over here to the variables tab, and in the selected cube, I'm gonna change this to input. And that way it'll be revealed to us in the FSM above. So now you can see if I come over here and click on our spawned array for each in its FSM, you can see that we now have this option for the inputs, and it shows our selected cube variable from that FSM template. If this isn't showing up for you, you might just need to refresh it. You could just click on this little ... and then find your FSM and click it again, and it should pop up. Okay, and so for the selected cube, we could say use this as our item. So we're gonna store that item here as last spawn cube, and the selected cube, same thing, last spawn cube. And then this finished event, we'll just say complete, and that'll send us down here to complete. So the last thing I'm gonna do here is add in an array add. So I'm gonna say cubes array, adding that last spawn cube. So what I'm gonna do is I'm gonna take this array for each, I'm gonna put in another state, and we'll say that here in our first state, we'll give it a loop state. So it runs through, let's say 10 times. And when it finishes, complete. And then it goes here to where we do our array for each. Okay, so we'll call this one create cube. And then once this is done, this will get sent down to the real complete. All right, so what we have here is it creates this cube, adds it to the array, loops this state 10 times, so we get 10 cubes in that array. And then once that's done, we go down here where we run this array for each state, which should be running this FSM template on each of those cubes in the array, which will change their colors and their sizes all independently. And then when that's done, we go down here to complete. All right, so let's see how that runs. Boom, there you go. A bunch of different sized cubes with different colors. There's a lot of red in this one. Let's, we got a couple of blues and a yellow. Let's try that again. Let's see if we get some more variation. Nice, got some more yellows this time, some more blues. And there you go, those are some of the many ways to set up looping systems with Playmaker. Be sure to check out our other videos to learn all the various features of Playmaker. Links to more learning resources are in the description.